So this question about ball bouncing off some walls, and so for this we've got to work out the value of k. And these questions are just work through them doing the same sort of process and see where it leads me to. So I've added a few bit of information on my diagram because we know these two paths, if you read the question, are parallel. That means I can add in an angle alpha. And then I can work out that the final angle here is going to be 90 minus alpha. I've then called my angle, the halfway angle here, I've just called that beta. And first of all, I'm going to look at collision 1, which I've highlighted a diagram for, so I've got with a slightly close-up diagram. So just dealing with one collision at a time. Parallel to the wall, there's going to be no change in the speed component. So parallel to the wall, if I resolve, I can say that u cos alpha is going to be the same as v cos beta. I can then look perpendicular to wall using my coefficient of restitution. So e is the speed of separation over the speed of approach. So the ball is the only thing moving here. And I can rearrange that. So here I've got two equations, 1 and 2, and you should be able to see that if I do equation 2 divided by equation 1, I'm going to end up with EU sine alpha divided by U cos alpha, so they're going to divide, and that's going to give me the U's are going to cancel, and I'm going to end up with E tan alpha, because sine over cos gives us tan. And then similarly with the other side, I'm doing V sine beta divided by V cos beta, so that's going to give me tan beta, and I'm going to call that equation A, because I'm going to reuse that in a minute. Right, once I've done collision 1, I'm going to move on to collision 2. I have a close-up diagram again here. So now we're coming in with velocity d. This angle here, if you look at the triangle up here, I can work out that that angle is going to be 90 minus beta. As we said before, its trajectory is now parallel to how it started off, which makes this angle 90 minus alpha. And then I can look again. So parallel to the wall, there's going to be no change in the speed. Then perpendicular to the wall, I can use the coefficient of restitution, which we know is Ke, and using the same thing and rearranging at the same time, as you can see from here what we're going to do, I can say that Ke, so that would be the speed of separation, which is going to be W sine 90 minus alpha, right, over the speed of approach. So the speed of approach is V sine 90 minus beta, and I can just rearrange that in one step as well. Right, so this isn't particularly helpful at the moment, but what can we do? Well, you could have done this prior to writing it like this. It's just the way I did this. If you think about a right-angled triangle, where this angle is beta and this angle is 90 minus beta, so if I look at this, if I label the sides relative to beta, that's the hypotenuse, that's the adjacent, that's the opposite. If I label the sides relative to 90 minus beta, that's the opposite, that's the adjacent, and that's still the hypotenuse. Okay? And so you can see from the triangle that, for example, cos of 90 minus beta, which would be the red adjacent over the hypotenuse, is the same as sine of beta. And I can use that to write these equations in a more useful way. So this one becomes V sine beta instead of cos 90 beta, W sine alpha. So that's going to be equation 3, and this one can become Ke times V cos beta is W cos alpha, which is equation 4. And now just the same way we dealt with collision 1, I can get an equation for beta. So tan, if I do 3 divided by 4, I'm going to end up with, so we're sort of dividing here, look at it. So you can see the v's are going to cancel. I'm going to end up with tan beta over ke. On this side I'm going to end up with tan alpha. Right, if I have a look now, if I substitute in my equation A from up here, okay, I know that tan alpha is the same as tan beta over E, so tan beta over Ke is the same as tan alpha, and tan alpha is tan beta over E. And if you look at this equation, you can see the only way that's going to be satisfied is if K equals 1, which is the surprising or not answer, and does seem like quite a lot of work just to get to the fact that K equals 1, and you might think, oh, I've got that wrong, but that is the right answer.